Welcome to the Switchbox speaker series. My name is Jack Maddens, and I'll be filling in for Juan Pablo Velez, who is out on paternity leave. Switchbox is a think tank that provides legislators and advocates with rigorous and actionable data on state-level climate policy. The speaker series is an opportunity for our community to indulge our curiosity for the latest policy and technologies at the forefront of state-level climate action. So for those of you who haven't been here before, here's how it works. We're going to do about 30 to 40 minutes of on-the-record presentation and Q&A, and then we're going to go off the record to allow for some more candor. So if you're watching this sometime in the future and you wish you could get in on that backroom conversation, then sign up and join the next Switchbox speaker series. Okay, now for what we're talking about today. So if you know Switchbox at all, you know that we spent a lot of time talking about building decarbonization every day on almost every Switchbox speaker series so far. Well, today we are breaking the mold and branching out to something that's been getting us really interested, and that's the carbon emissions from the industrial sector. Heavy industry accounts for about a third of US emissions. The Biden administration recently announced about $6 billion in grants for industrial decarb, and New York and California have passed some path-breaking legislation on the regulations of concrete. So Mikhail Haramati from NRDC is here to tell us what states can be doing, must be doing to decarbonize their industrial sectors. Mikhail is the state industrial lead for climate and energy at NRDC, and she's done similar work at NYSERDA and at the California Energy Commission. We're really lucky to have her with us. So with that, I'll ask you to take it away, Mikhail.
Okay, thank you for that. I'm very excited to be here and excited to be talking about industrial decarb. It's kind of fitting that I'm on a Switchbox webinar, given that I come from the building sector. I've been working on building decarbonization for about 15 years and recently made the switch over to industrial decarbonization. And it was really a realization that the materials that go into our buildings are a huge contributor of the emissions of buildings, especially as we've been successful over time in increased efficiency and fuel switching, and our buildings operations are getting cleaner. Now we're really starting to need to think about how those buildings are constructed, how the materials themselves are mined and manufactured, and what happens to them at the end of life. Talk a little bit about what I'll be going over today. So I think there's this question of like, why industry, right? And why is it getting increased attention? And I'll be talking a little bit about the different sector approaches that we're focusing on at NRDC and what those interventions look like. And then I'll be giving a few examples at the state level. And I think that given that this is a new topic, probably to many on the call, kind of focusing on like those threshold questions around like why this and what even is possible is kind of the right level. So that's where most of my presentation is, but happy to talk about more of the specifics during the Q&A. And I have some extra slides on federal funding and just all of the money and initiatives that are going to the states right now. There's been a lot of work through the Biden administration, and a lot of funding has come out and is being funneled down to the states. Okay, great, wonderful. Okay, so let's go ahead to slide 3. And so I talked a little bit about what I'd be covering. And then this is, I think, a really important chart to kind of keep in mind. So this is between now and 2023. The industrial sector is on track to eclipse all other sectors, emissions from all other sectors. And this is in part because the transportation sector and the power sector really have a reduction in emissions because of all of the excellent work that has been done in this space and that we're continuing to do. Similar to buildings, right? We're building new buildings, but we expect emissions to stay pretty flat. But really, we haven't done much on the industrial sector. And this is because historically, this has been considered a hard to abate sector. And it's also trade exposed. So particularly in the US, this is one of the reasons why there hasn't been much pressure that's been put on domestic production, right? Concern about jobs, about continued offshoring, about losing a lot of the domestic manufacturing and having it go elsewhere. And so what we've heard, and I heard this when I was working for the state of New York, and when we were working on developing the state scoping plan, that the industrial customers just feel like their margins are too thin, and they can't really afford to be making these upgrades and reductions. And if we're looking for, let's say, an 80% reduction in economy-wide emissions, they'll just be part of the 20% that doesn't reduce. And what we're learning now is that really globally, we need to be going to a net zero scenario. And now suddenly all of these sectors and producers that have kind of been given a pass in the past have to figure out what they're going to do to actually reduce their emissions, because we're in a place where we can't really afford to have anybody not taking action. And from the industrial side, where the emissions are coming from are things like chemical production, refining, creation of iron and steel, producing food and drink, producing cement, paper industry, aluminum. These are kind of like at the national level, like where the majority of the industrial emissions are coming from, aside from the power sector. And they're also a pretty big source of air and water pollution. So when we think about equity and we think about impacts on local communities, it's often these industrial customers that are most implicated. Let's go to the next slide. And then, thinking specifically about this trajectory in order to stay within 1.5 degree increase globally, we need to be reducing industrial emissions by 2/3 from 1990 levels. And if we do nothing, there's going to be this huge gap, right? And in fact, industry is going to be a large contributor to global warming instead of a part of the solution. And let's go to the next slide. So at NRDC, the things that we've been thinking about really are how to kind of acknowledge that industry is essential for the clean energy solution and for critical infrastructure that will become more and more important, right? Things like roads, schools, hospitals, as we deal with the impacts of climate change, ability to have clean water, and the ability to have electricity and produce clean cars and trucks and transportation vehicles, and all of the turbines and panels and stuff that are needed in order to produce clean electricity. All of that comes from and is associated with emissions from the industrial sector. And we really can't get away from that need. So how do we modernize this production in such a way that we can reach net zero emissions by mid-century? And how can we demonstrate and cultivate that next set of solutions for the clean energy economy? And what this looks like for the work of our team is we're thinking a lot about energy efficiency, about electrifying where possible, fuel switching, and about efficient use of materials. And specifically in the US, we're focusing on cement, steel, and aluminum production. So for cement, thinking a lot about carbon capture and storage. We're thinking about ways to reduce the amount of clinker in concrete mixes. Clinker is the source material of cement, and to substitute it with other materials or substitute a portion of it with other materials. For steel, we're looking at hydrogen direct reduced iron making and molten oxide electrolysis, which is using hydrogen and electricity to produce primary steel. And for aluminum, we're looking at increased secondary production, so like recycling and reuse in the US. And we're looking at electrification and decarbonizing the power grid, and development of inert anodes for primary aluminum production. So that's kind of like the focus area that we think is the focus areas that we think are needed in order to, in the US, reach that 2050 goal. And now I'm going to talk a little bit about kind of where we are for each of those areas and what that looks like in terms of US manufacturing. So let's go to the next slide. Okay, so thinking about cement. So cement is the critical element in concrete. For those who are new to production of cement and concrete, in order to make a road or a sidewalk or a foundation or a retaining wall, you need to create concrete, and concrete is a mix of cement, sand, aggregate, and what are called admixtures. So kind of like additional things in the mix. And it's a little bit like baking a cake where you have a different recipe depending on like the type of structure that you are creating. So you might have one recipe for like a sidewalk cake and another recipe for a building foundation cake, for instance, and they have different ratios of each of those. And concrete is inherently a local and perishable product. And what that means is that there's about an 1.5 to 2 hour radius around a concrete plant where it takes about an 1.5 or 2 hours for the concrete mix to start curing once it has been dropped into those trucks. So if you recall the sort of like rotating concrete mixer trucks that maybe like you remember being into as a kid, or you have a toddler or young one that's like fascinated by. Those go to a concrete batch plant. They have the materials dropped into the top of the truck from a hopper, and then they start mixing while they're en route to a job site, and then they pour the concrete into a form and it starts to cure. So that means that concrete plants need to be located next to where building is happening. And similarly, the closer cement plants can be located next to that, the more advantageous it is in terms of reduced costs. So cement plants tend to be located near population centers on limestone deposits. So they mine the limestone on site, and then they grind that limestone up, superheat it through a kiln, and in the process of superheating it, it becomes what's called clinker, which is like sort of almost vulcanized rock, right? And then the chemical process of creating that clinker releases CO2 from the limestone. So the CO2 emissions from creating cement are both from the fuel that's needed to superheat it, and then also the CO2 that's released from the bonds of the rock in that chemical process of heating it. And then it gets ground again, and then that's what is put in bags as cement and then shipped to either concrete plants or sold at places like Home Depot for individual use. So that's why reducing cement is really important, and cement substitution is really critical for reducing emissions associated with concrete. And so you can see here, Texas has the most plants in the US, followed by California, and there's also a large distribution in the Mid-Atlantic and the Midwest. And we import about 15 to 20% of the cement that's used in the US. So there are also import terminals located throughout the US, typically around population centers. And let's go to the next slide. So for decarbonizing cement and concrete, what this looks like on the supply side is increased efficiency at the plant. So it could be doing things like pre-calcining the cement before it goes, or I should say the limestone before it goes into the kiln. So it's like using like the waste heat from the kiln instead of venting it to heat that ground limestone, so that it only needs to be heated a little bit more by the kiln itself. Switching from fossil-based fuels like coal, fuel oil, to cleaner fuels like electricity or natural gas. And electrifying plant operations are really good ways to increase efficiency on on the process side, many of the US cement plants are actually quite old. And so they're using older technology than is standard in Asia, where a lot of the cement is where the majority of the world's cement is currently produced. Also at the plant level, looking into carbon capture, so capturing CO2 at the plant level, possibly finding ways to embed it into the mix through technologies like maybe carbon cure, ways of utilizing that CO2. And I'll note that unlike for like enhanced oil recovery or carbon capture, utilization, and storage on the fossil fuel side, those actually lead to increased use of fossil fuels, increased production. On the cement side, it really does get locked into the rock. So it's a little bit of a different nature when we talk about carbon capture, utilization, and storage for cement and concrete. So that's a very real solution, I think, for environmentalists, where it's not on the oil production side. We're also looking at cement mixes and blends. So this is doing things like replacing the amount of clinker in the mixes. So there's something called supplementary cementitious materials, and these are essentially alternative glues that can be used in place of a percentage of the clinker. So maybe you replace 10 or 20% of the clinker with a material like fly ash or coal, and also slag from steel production, or like pozzolans or some vulcanized rocks that can act as a glue when ground up and used in as a percentage replacement of clinker. And there's also things that can be done kind of on the mixed side, aside from the cement. So like optimizing the size of aggregate of the pebbles that go into the concrete mixes. And then on the demand side, doing concrete recycling, avoiding over specifying for strength, which leads to more cement used in mixes than would be otherwise. And then looking to the purchasers of cement and concrete and asking them to make what are called advanced market commitments, which say this was used for vaccine development when we got the COVID vaccine, and it essentially says if you build a product that meets these specifications at this price, then we will purchase a set quantity of that product, and that kind of acts as a feed-in tariff or a guaranteed demand that can then be used to finance production of those new materials. So that's pretty exciting. So that's what we're looking for cement and concrete. And now I will go to steel. Whoops. Okay, there we go. Steel. Yes. Nope, I went too far. So for steel, I'll note that steel is 1% of greenhouse gas emissions in the US and about 7% of global emissions. And here you can see where the steel plants are distributed in the US. So primarily the Midwest area, right? Well, what we think of often as the Rust Belt. And we say that because really what we have now today in terms of plants in operation is a huge reduction from former production levels historically. So we have three primary production plants with basic oxygen furnaces, which are, the same furnaces, same technology that's been operating for the last 100, 200 years. These are Gary Works, Burns Harbor, and Indiana Harbor. And so you can see them located here. And then there are also what are called mini mills, which are secondary plants, which are producing steel from recycled materials, and those tend to be typically electric already. So most of the emissions from steel production in the US are from blast furnaces, those kind of historic furnaces. And Cleveland Cliffs is a company that owns all of the US blast furnace facilities for primary steel, and they account for 65% of emissions, despite making only 30% of the steel in the US. And that's because they're just inefficient technologies, and they are using dirty fossil fuels in that production. So I will go to the next set, which is our solution set for steel. And our goal here is to decarbonize the fuel supply to the plants themselves, and then to also lower the emissions associated with processing and reprocessing the steel in the US. So we're looking to integrate with our hydrogen team at NRDC to convert or build new plants that are using hydrogen into furnaces via direct injection. So that's a more efficient process. And we're also looking at increasing the use and collection of scrap steel in the US. And as I mentioned, those mini mills, the ones that reprocess recycled steel, are actually pretty efficient and primarily electric. And right now, there are a number of incentives. So there's a hydrogen production tax credit at the federal level. So we view hydrogen direct injection, the electrification process for primary steel production, is pretty cost competitive. But we do have a fair amount of trade exposure in the US for steel production. So we have about 25 to 35% exports and a 15% net trade imbalance for steel. And a lot of steel, the majority of the world's steel, is being produced in Asia. So we're looking to new processes. Molten oxide electrolysis is another one that uses electricity, and it takes iron ore in an electrochemical cell, and it converts it into molten pure iron using electricity. So that's still in the R&D stage, but that's one of the potential solutions that we're looking at on the innovation side. And then you can see this image here. It's a rendering of the first hydrogen DRI plant that's being built in Boden, Sweden. So that's an example of the type of technology that we want to be demonstrating here in the US, in addition to creating jobs and being able to continue to support those local economies. So I will go to the next slide now, which talks a little bit about our steel plant advocacy. And this is really, whoops, like a little bit of a delay here with these buttons. So for primary steel, we're asking them to shift to hydrogen, direct reduced iron making, the H2DRI, with hydrogen and electricity. And we want to modernize this industry in the US. We want to prevent further loss of production. And we want to demonstrate that this technology works so that it can be exported to the rest of the world. So that's kind of the sweet spot of where we think that the US value add is, that we have the ability to be demonstrating these new technologies, even though we're not producing the vast majority of the steel for the world. Other countries maybe are not doing this type of innovation, and we think that it's pretty critically important. So for aluminum, one of the other high emission metals that I mentioned, we actually don't have that many aluminum smelters left in the US. So 2 of the plants on this map have actually closed. So we're looking at 2021 data. And the aluminum industry is really struggling to stay afloat in the US. So the remaining plants are in Indiana. You can see the Alcoa facility here in New York, up in Messina, South Carolina, and then Kentucky. And the New York Messina plant, the Alcoa one, is subsidized with a lot of NYPA power, hydropower. So that's, it gets cheap power and it gets clean power. So that is sort of beneficial for that facility, but the other ones are really kind of struggling, and that one frankly probably is as well. And they're large contributors to the local economies and large sources of jobs, so politically pretty important. So in terms of the solution set for aluminum, we see there as being sort of less of an opportunity for aluminum emissions reductions in the US relative to steel and cement, just because there's not that much being produced here anymore. And very, very little on the way of primary production, but we see an opportunity for secondary production. And there's actually a great Canary Media article that came out a few days ago that quotes Caroline Kim of our science office that explains what that looks like, and the importance of really taking out the portions of the like recycling system that we can in terms of like the cans and like car parts and the things that actually are recyclable and recycling them rather than having them go directly to landfill. So there are a lot of recyclable materials in the US that are not being recycled. So being able to improve the collection of those materials is pretty critical. And then also looking at electrification and equipment upgrades for the secondary aluminum producers. And this goes hand in hand, as I was saying, with decarbonizing the electric grid and electrifying those plants and powering them with renewable sources. Okay, and then I just wanted to show, so these are recent awards from the Department of Energy's Innovation Office. And these are awards, as I mentioned, that are going to the state level, individual companies operating in different states. So these awards, the OSED demonstration awards that came out earlier this year, are actually the largest source of federal industrial funding given to date. So this is a huge amount of money, and a number of them are located in key states that we're looking at NRDC. So I've highlighted those. So among the ones that we're focusing on, California, Michigan, Ohio, Pennsylvania, Colorado, and there's a fair amount of overlap with like who's getting, what types of awards. We're looking particularly at the cement and concrete, iron and steel, and the aluminum, but you can see there awards that have been given for all of those high emission production sectors within industrial. And then thinking a little bit more holistically about like, what the policy intervention approach looks like. So I talked a little bit about advanced market commitments on the demand side, right? About the ability to harness future demand using government procurements in order to say we will buy this product and we'll buy X amount of this product if you can build it. We're also looking at LECLA, and apologies for not spelling that out, but that's the Low Embodied Carbon Concrete Leadership Act, like we have here in New York State, and that requires the government, the state government, to focus on procuring low carbon concrete when it's procuring concrete. So then it has to figure out like, how do you know that it's low carbon concrete? You have to submit environmental product declarations, which are like nutrition labels for concrete mixes. And so that then you need disclosure, right, in order to know what's in those mixes. So all of that kind of needs to be put in place. That's one thing that we're advocating for. We're also looking at tax credits and different ways that those can be used both at the state and federal level. And then also for preferential materials like the state of New Jersey is doing as part of their Low Embodied Carbon Concrete Leadership Act. The federal state Buy Clean partnership is very influential. So this is a partnership that's set up by the Biden administration, and it's working with a number of priority states in order to get them to harness their procurements that are already happening, their ability to purchase large materials, to specify cleaner materials and materials with lower global warming potential. We're also looking at building codes, state building codes, local building codes, county building codes. We're looking at project-based global warming potential limits. So looking at specifying limits for specific products. So this is the case in New York, for instance, where New York has adopted emissions limits for concrete that go into effect next year. And so all of the companies that are doing business with the state of New York will need to provide environmental product declarations if they want to be securing those contracts, right? And they'll have to show that the concrete that they're providing is within the limits that are specified by the state of New York. We're also looking at performance specifications, use of permitting, and clean product standards. And then on the supply side, we talked about this a little bit with cement, aluminum, and steel. And that's thinking about demonstrating these low carbon materials, looking at green steel demonstrations, demonstrating carbon capture and storage technology. So there was an OSET award, a couple OSET awards for this, for the cement side across the US in the different states. We're also looking at emissions limits, utilizing cap and invest at the state level, as well as corporate incubators, partnerships, and then really thinking about reporting and benchmarking and the development of tools that are going to be needed to track all of this and to show progress, and house this data, and then how we train the workforce, and what the financing looks like. So this is kind of the universe of what we're focusing on, and it's kind of a new space. And so that's why I think it's useful to kind of go over all of this. And I apologize, it's a little bit on the dry side. I will go now, I think, to kind of what we're doing, which are some of these state advocacy examples. And I wanted to start with the Buy Clean state. So Buy Clean, as I mentioned, is harnessing the procurement that states are already doing. So if they're going to be like building a new bridge or a new university campus, then within the specifications that are part of that contract, in the solicitation documents, they'll say you need to provide low carbon concrete for this project, and it needs to meet these other requirements. So that's how Buy Clean works, and it can be for a variety of things in New York. It also covers different environmental standards and like office equipment and things that have to be recycled, or paper made from recycled content, but it's really kind of using those procurements for to enforce environmental standards. So a number of states have passed Buy Clean requirements in addition to the federal government. New York and New Jersey. California, I'll talk about in a minute. It was the first state to pass Buy Clean in 2017, but their Buy Clean does not include concrete, so that's a big omission. Colorado, Oregon, and Washington did. Washington passed theirs earlier this year, after many years of trying, actually, and theirs covers concrete, steel, and engineered wood. And then it's been proposed in a number of states too, including Illinois this last year, and Connecticut. So lots going on the Buy Clean side. And I think what's really interesting about Buy Clean to me is that it's an opportunity to like use like an existing mechanism to get reduction at like no cost really, or very little cost to the state. Some of the estimates that I've been hearing for cement and concrete emission reduction is that it's possible to get 10 to 20% reduction in emissions just by asking often on these projects, with no additional cost. And that's because nothing's really been done here yet. And that speaks to the fact that this is an area that has a lot of low-hanging fruit, and it's why I'm super excited about this sector. So coming from the building space, having worked on buildings for a really long time and building efficiency, it feels like we're like trying to like wring out more and more savings from like a smaller pie. There's just less there, and we're reaching further and further up in the tree because all the low-hanging fruit has been picked. And in industrial, like, people haven't been doing much, and it means that without a lot of effort, there's a lot that can be done. And I think that that's really exciting, and I think that it makes a very compelling case for these reductions, and doing things like these procurements within the government and just saying, you should reduce emissions by 10% on this project from the concrete and cement, or by 20%. And that's the requirement if you want this job. Your proposal has to include a way that you're going to do that, and show us what that way is extremely compelling. So this next slide, and I'll distribute these after the call, just kind of shows the specifics of like what the Buy Clean includes for the different states and entities that have passed Buy Clean. So you can see New York's Buy Clean includes concrete, asphalt, glass, and steel. And New Jersey only has a requirement for concrete. And California, for instance, has steel, glass, and insulation, but not concrete. And some of them are for transportation and buildings, and some of them are just for one or the other. And the more that I've been working in this space, the more I've come to realize that we really need both, because these materials are used in both spaces, but the approaches are quite different since the projects are planned differently and the procurements are different as well. So just lastly, kind of giving a couple more specific state examples. So California in 2021 passed a net zero cement law. So this is the first state to require that all cement used in the state of California be zero net emission by 2045. So this is significant for two reasons. One is that it's the first in the US, and the second is because California actually produces and uses a fair amount of cement. It's the second largest cement producer in the US, and there's a lot of building in the state. So the California Air Resources Board, which is the one that does the cap and trade system in the state and does air regulation, they're tasked with implementing this. And they're over a year late in coming out with their strategy for how to approach this, but I think it's really exciting that they're looking at this and that this is a requirement in California, and they're integrating very closely with their cap and trade system in California. And then lastly, I want to talk about CalGreen. So CalGreen is California's Green Building Code. And earlier this year, the Building Standard Commission included these kind of like specified approaches for how to comply with embodied carbon reduction for the state of California. And it has this path for individual cities and counties to adopt one of these approaches at one of these levels. So it could either be a prescriptive approach for building reuse, and they could go with mandatory tier 1 or tier 2, or they could focus on whole building life cycle analysis and looking at, for like an individual project, for like a house or an apartment building, reducing a certain percentage of emissions for those materials from a given baseline. Or they could adopt specific material limits for concrete, for instance, or other materials that they specify. So either using reused materials or calculating emissions reductions from the materials for new construction for a building, or looking at limits for individual materials. And this is, I think, pretty amazing and groundbreaking because it gives flexibility to the cities and counties on how they want to implement it. And it requires that everybody do something, right, for these larger buildings. Which is a thing that has not really been adopted in the rest of the US yet. So we're looking to expand CalGreen or some version of that into other states to start adopting emissions limits for or emissions reductions requirements for new construction. And then also thinking about how to lower the emissions associated with cement production in those states. So with that, I will conclude and see what excellent questions we have.